So I'm going to try and prove kinetic energy is equal to half mv squared for us. So to do this, I'm going to have a block. I'm going to exert force on this block in this direction. Let's say the block has a mass m. He's going to accelerate from his initial velocity. Let's put his initial velocity at 0 to make things easy for us. And he's going to accelerate to a new velocity. Let's say that new velocity is v. He's still a mass m. Now, because we've exerted a force on this and he has moved, therefore we have done some work. And that work is equal to the force times by the displacement. What I'm going to be able to say is because the energy's not gone anywhere else, we're ignoring air resistance, all of that work is going to go into kinetic energy of this object. So, let's try and substitute things into here. So this force, well, we can just say force is equal to mass times acceleration, the mass of this block times by his acceleration. So let's put that in. So MAS, mass times acceleration times displacement. Now let's try and think what we can replace acceleration with. Well, the definition of acceleration is the change in velocity over time. And I've just said that u is 0, so I can just ignore that term. So we're going to get mass times by the velocity over the time times by the displacement. So our next little step here is this displacement value, and this is how far he has moved from the first position to the second position. So displacement, I can say, well, an average velocity, what is your average velocity? Average velocity is equal to your total displacement divided by your total time. Time to get from there to there, which is this time that we've been using here as well. So I can rearrange this and say that S is equal to the average velocity times by the time. Annoyingly, we've got average velocity here, and this isn't the average velocity. This here is the final velocity. So I want to do something about this average velocity term. So I can say, well, how do you work out an average velocity? It's the values plus together divided by how many values you have. So I can say, well, average velocity is equal to u plus v, the two values of velocity I have, divided by how many values there are, 2. Right, let's substitute these back into here. So I'm going to get mv, remember that's the final velocity, over t, times by the average velocity, times by t. T is going to cancel. Then I need to substitute this value in here, and I can just conveniently say, well, that original u is 0. So that just substitutes back into here. So I'm going to get the work done, which was also the kinetic energy, is equal to the mass times by the final velocity. Replacing here, we've got v over 2. Those can just go to v squared, so I can just say KE is equal to mv squared, and I can just put this 2 at the front as a half. Kinetic energy is equal to half mv squared.